Hello, welcome to Ekidel. We are train future civil and structural engineer. My name is Justice 𝔼𝕚𝕚𝕠𝕝𝕝 and I am your instructor. Today, I will be showing you some common mistakes most structural engineers make when performing their design on any structural design software. Now, for today, I will be using the software Protastructure to demonstrate this. Okay, let's begin. So, following this now, I will then head on to my plan view plan here, which is the plan layout and all that. So if you look at the plan layout now, you can see that this is basically an 8-story building and all that. As you can see from the tree here, an 8-story building, and if you count the number of floors from the 3D view here, you will see that we have up to 8 floors and all that. Let's begin now. Beginning from here, this is the what? This is the floor 1, floor 2, floor 3, floor 4, floor 5, floor 6, and floor 7, and the final floor, floor 8, which is the roof. Okay, I didn't count this other one here because this is just covering for the lift and for the stairway. Okay, and all that. And also this other portion here is a ground floor, and since we are basically using British method of counting, that means that we will not count this other floor here as story 1, but had it been we are using American method of counting, we would have counted this one as a story, and all that it will now become to 9 story. Okay, but right now we are using the British method of counting of stories, and this is 8 story. Okay, back to our plan view right now again, and then now the first mistakes I will show you that most structural engineers make is not trying to do recognize their primary beam and their secondary beam. Okay, most structural engineers takes their secondary beam to carry their primary beam, and also most engineers also don't even identify that at all. Okay, for example, now you can see that this beam here, you can see these 2 beam here, this is a beam and this is also a beam. Now in this case now, which among these beams is meant to be the primary beam and which is meant to be the secondary beam? Now before we come to that, let's now look at first how this beam is being modeled. Okay, looking at this first, the whole modeling of these 2 beams here is just rubbish. Okay, now you can see that this beam is crossing each other. You can see that this beam is crossing from this beam here up to this beam here, and also this other beam also is also crossing from this beam from this column 13 up to column 12, and no one of these beams is carrying each other. That means they are just crossing each other like this. Okay, which is bad. Okay, one is meant to carry each other and then continue again if there is any continuity. So in this case now, this type of modeling is rubbish. Don't ever try that when you are doing your structural modeling or your design of structures. Okay, so in this case now, one is meant to be a primary beam and the other is to be a secondary beam. So with this now, the first thing you have to look out for when you are trying to identify your primary beam and secondary beam, 2 things should come to your mind. One, which one has the shortest length, okay, or the shortest span. Okay, that is the main primary beam. Anyone that has the shortest span is meant to bear more weight than the other. Okay, and that should be your primary beam. Okay, now that is in just one option. Now the next option now that will come to your mind is, what if the one that has the shorter length doesn't have enough support at the both ends of the beam? Okay, will it still be the primary beam? The answer is no. Okay, so in that scenario, or in that case, the one that carries the most support should be the primary beam. For example, now looking at this beam now, these 2 beams, this one here has its own support on the wall on one end, which is the J end here, and this other end here, it has its own support on the I end. So in this case now, or in this scenario, this one here does not have enough support system compared to this other beam 16 here that has its support on column 12 and on column 13. And also if you look at the length also, is also shorter than this other beam 63. Okay, so with this now, this beam 16 now will now become the most primary beam, and this other beam 63 will now become the secondary beam. And you can see how this thing was modeled, which is bad. Now if you are the type that models your structure like this, you will be having issues after your structural design, because there is no way they are going to construct this beam like this by crossing each other like this. No. So you have to put into consideration when you are doing your structural modeling what is going to happen during the construction and all that. Okay, so with that, I'm going to remove this beam right now, because this beam is not meant to cross each other, as you can see there. Then I will now provide it what? I will now provide it to support itself on that system. Okay, so what I'll do right now is just to come here, take this beam property right now, take it, and then reinsert this beam. Okay, now I will need to turn on my grid line, because I turned it off, because I like to have a clearer view. Okay, so let me just turn it on back now, and then insert my beam afresh on that particular side. Okay, so right now that the grid lines are being turned on, let me now begin to now insert my beam back which is from here all the way down. Now it's meant to stop directly at this place and not to just cross, okay, and all that. And even if you want to cross, they will ask you a question: do you want to divide the beam? Always say yes, don't say no, because if you say no, that means that okay, for example, if I want to cross this now and keep it here, they will ask me a question. If I say yes, that is fine, it will divide the beam by 2, okay, and then one will be on one span. You can see that you can now see that we now have two beams. One is what? One is sorry, just go there and just undo that. Sorry for that. Okay, we now have two beams now. One now is what? Beam 93, and the other one here is beam what? 92. Can you see that? Compared to when we have just a long beam running from here all the way down here. So in this case now, you can now see that because we now have these two beams now supported by this beam 16, this beam 16 now becomes the main primary beam to this beam 93 and beam 92. Okay, so that's fine. So then the next thing now I will do, let me just show you that again. So you can now see that this beam now is now the beam that is being supported by that now is now being supporting what? Supporting beam 92 and beam 93. Okay, so you can now see that this is the way to support that. So many people make this mistake on almost all their structures. The same thing repeats itself here. As you can see that in this case we have only one beam here, which is beam what? 74, compared to what we have here, two beams, this and this. So this beam 74 right now is meant to break, all right, at this beam 17, because this beam 17 is the main primary beam that is carrying these two this beam 74. So in this case right now, we are not going to make it to cross as they are crossing like this. We are going to make it to cross something like this. This beam 74, we have to cross like this, and then support itself on this beam 17 here, and then jump the beam 17, and then continue again from this other side now, and then go. Okay, that's fine. So with this now, we are also going to remove this other beam here. So I'm going to remove this beam now from here. Okay, if I take this beam off from here now, I'm then going to reinsert the beam again by now coming here to reinsert the beam by doing something like this. Sorry, that was a mistake. I click on delete. Let me just undo that, and then go right click again right now on the beam, right click now, and then go to beam what? Properties here, and then reinsert the beam from here all the way down and stop it here. Okay, that means that this beam this beam 17 is now carrying this beam at this end, and again continue again to the next support, which is also a beam end support. Okay, and sorry, okay, let me see that. Okay, that's fine, and then continue with that. Okay, now you can see that this is the major mistakes most people make when performing their structural design, is to not doing what? Identifying their primary beam and what? Secondary beam, which is very, very important, because if you miss that, then your structure will have issues. Okay, so the number 2 mistakes people make, which people overlook a lot and structural engineers don't take that into consideration, is not identifying their end conditions. They are either fixed end or pin end. They just depend on the software, which is bad. Okay, now during the era of manual design, you have to do what? Identify which one is a hinge end or pin end, and the one that is what? A fixed end. Now when the era of software came into existence, most people feel that that principle does not count any longer. No, it still can't, because the software gave room for that. Now, let me tell you how most of all these engineering software are being programmed. Knowing that the mission of every engineering software is to design against what? Against structural failure. So with that, what do? They just make everywhere to have a fixed end. So at default, Protastructure consider every place as what? A fixed end. And if you don't change it by yourself, as a good structural engineer you are, what it means is that you are considering every end of beam as what? Fixed. And that will have, yes, it will make your building to be, yes, it is okay, but it will have impact on the cost of that structure during the construction. By the time they check the economic value and the cost of that building, you will see that it will be more expensive compared to the engineer that applied pin end or hinge end on its own structure. And that's very, very important when you are bidding for a contract for with other engineer to a client. Okay, so when you are bidding for a contract, it will enable you to make your design to be what? Economical, and not what? Economical. So when you assume, or when you don't apply hinge end and fixed end on your structure, then what happens? It will make your structure to be what? To be non-economical, like to be non-what? Like it will be expensive and all that. So in that case, to make your structure to be what? Economical for the client to afford and all that during the construction, you must have to do what? Apply your hinge end or your pin end. Okay, and don't take everywhere to be fixed end. Yes, there are some places that you are meant to consider as fixed end, and there's some places you are meant to assign as what? Hinge end. Most people see this as what? Stress and all that. But if you have ever done manual design for a structure of this of this size before, you will be able to value. Let me just show you the size. So if you have ever done manual design for a structure of this size before, let me say you do it manually and all that, you will be able to value the use of the software, knowing that the software help to reduce the time of analysis for you and the time of design for you. Because basically, when you're doing manual design, you have to first consider what? The structural framing and all that of all the stories. And when you're done with that, you will then begin the calculating for the load. And when you're done with the loading and all that, getting your load factor, you will now use the load to now begin your building building analysis. And when you're done with that, you will now, just to save time for yourself, you will now pick the most maximum, or try to group most of your members together, and then pick the maximum moment, the maximum share, and the maximum load and all that, and then design for each of the structural member based on the flaws and all that. And then when you are done with that, structural analysis and all that, you will then pick all those values and then begin your design, and then move on to your what? Onto your structural detailing. Now, if you look at all these stages now, you will see that it will take basically 1 month or 2 months to begin to finish up your this thing, because those days, 40 years ago, we performed structural detailing with hand and with your pencil drawing board and that. But right now, you can see that the software is making things easier for you. So even if the software is making things simpler and easier, you must not give your responsibility to the software as a structural engineer. You will still need to impute your idea, your sense of reasoning, and everything into the software and all that. That is why every software gives room for what? For check, or for what? Interactive design. That is because they want you, the structural engineer, to interact with the software. So don't just depend on what the software gives to you. Most people, when they just design their structure, once they see that everything is green, everything is okay, everything is green, they just go and start printing out their drawing. That is bad. I have seen most professional engineers do that using this software. Once they design their structure and they look on their on their status and everything looks green, they will just go ahead and begin to bring out their joints, and you will see that their joints will be messed up, because you will see some beams will be carrying Y50, some beams will be carrying Y25. A beam that is able to that would have carried diameter 16, because of the software did what did some kind of let me say grouping and all that, it will give the beam to be what 25 and all that. So you are meant to check the software and don't depend only on what the software gives to you. For God's sake, you are meant to check what the software is bringing out and all that. The software is only there to help you facilitate your work. Why you as a structural engineer is the one that is going to use the software and also input the parameters, and after the design analysis that the software have done, you will now begin to check each of the structural members to see if they are okay. So you as a structural engineer is meant to do the checking on the software. All right, and don't depend on what the software is given to you. So in that case right now, let me now introduce to you what is about hinging and fixing. For example, looking at this structure right now, this is how most of you models your structure. So this is how most of the structural engineers have their buildings, as it is like this. As you can see, the end of the beams does not have any end conditions and all that, and also you can see the this continuous end and all that. So basically, I want to explain to you right now what is a fixed end and what is a hinge end or a pin end. So basically, this is how your when you're done with your modeling, this is how it appears and all that. So at default, like this, at default, Protastructure considers every beam end or every place to be what, or every junction to be what, a fixed end. So in this case now, this beam right now is a fixed end, and this here also is a fixed end, and here also is a fixed end, and here also is a fixed end. So every beam, this software considers every beam end to be what, fixed. All right, but that is not how it's meant to be in reality. All right, there are some beams that are meant to have what, hinge end. For example, you can see that this beam right now is a cantilever, knowing that this sign here shows that this is a cantilever. So just as this is assigned as a cantilever, so also you will also assign some beams to be what, to be a hinge end or a or a pin end. So with that now, I will now begin what, to show you how to assign what, hinge end, and where the hinge end or the pin end is meant to be applied, and where is a fixed end. So with that now, let's now begin with this here. Knowing that this beam right now, this beam 8, all right, knowing that this software have already assigned that this is a cantilever beam. Yes, that's true, that's fine. But on this beam 8 right now, the software is taking this end of this beam 8 and this end of this beam 8 as what, fixed end, which is not meant to be. Now let me now recall your sense or your what, or your memory back to when you are in the university. And if you're a student watching this right now, let me still recall your memory back when you were taught structural analysis or end condition, knowing that the moment at every end of a beam is what, it tends towards 0. All right, the moment at every end is equals to what, 0. Okay, so the moment at every end of a beam is what, 0. So knowing that right now, knowing that the moment at every end of a beam is what, 0, that means that the at every end of a beam is meant to do what, have 0 moment, and the only thing that gives you 0 moment is a pin end or a hinge end. All right, beam and hinge, they still mean the same thing. So the only thing that gives you 0 moment is a pin end or a hinge end. Now fixed end does not give you 0 moment, because the moment at the end of a fixed end is either 1 to what, infinity. So because of that, fixed end are meant to do what, have moment. So knowing that the moment at every end of a beam is 10 towards 0, so this beam right now, this beam 8 has an end here on this column, because there is no continuity on this beam. Had it been we have a continuity on this beam, something like this. Let me just show you right now, something like this. Let me just show you. Had it been we have a continuity on this beam, something like this. Let me just show you something something like this, let me say there's a beam here running here, then this point of this beam 8 wouldn't have been an end. Okay, this point here where the beam will end would have been an end, but since there is no continuity of this beam 8 and this beam 8 ends directly on this column 1, that means that this end of beam, which is the J end at this place, is meant to be what? 0. Okay, is meant to be what? Moment at what? 0. And in that case, that means that here is going to be what? A pin end or a hinge end. And the same thing happens to this place too. Since there is no continuity of this beam, let me say there is no continuity of this beam of this beam 8 from this point all the way down to anywhere, that means that the end of this beam 8 is on this beam I, on this other side of the beam. And in that case, every end of the beam is meant to be what? It's meant to be what? Have what? 0 what? Moment. And in that case right now, that means that this place is meant to do what? To have what? A pin end or a hinge end, because as it is right now, the software gave it that this is what? A fixed end, and this end also is a fixed end. Like I said again, they are trying to do what? Design against collapse. But even if you mark it to be what? To a pin end or a fixed end, it is still, if your structure is stable, it is still stable. Okay, now the impact that this thing will happen, that this structure as this software has given to us, pin end to pin end, will happen is that you will be having more reinforcement, because fixed end generates reinforcement or more reinforcement at the what? At the supports. All right, knowing that the diagram of a fixed end moment is something like this. If you have a beam like this, let me just say a beam like this, all right, and then you have a support like this, a column, let me just say a column like this, all right. Now you can see that your diagram will go up something like this. Let me just say we have to go something like this for a fixed end. It will come like this. All right, so in that course right now, having this kind of curve, all right, on the moment, that means that here requires what? More what? Top bar. Okay, but if it is a pin end, knowing that moment at every end is what? Meant to be 0, you will see that your moment diagram will start directly at the 0 line, okay, which is the what? Which is the neutral axis. It will start at the 0 line here and then move. All right, so since this diagram for this moment didn't go upward, that means that this place actually does not require what? Any additional top reinforcement. But just for the case of design, we will just provide what? 2y16 or 2y20, or 2y16, which is the minimal reinforcement. Okay, so the code requires that when you are having a pin end, yes, even if that end or that support does not require any top reinforcement, it is necessary to provide what? A minimal reinforcement of what? 2y16 at the top. Okay, that's because that will help to hold the legs of your links. Okay, it will help to give stability to your links, not that it is doing any work. Okay, it's not doing any work. So when a moment is 0 at the support, that support can purely that beam can purely stand without a top reinforcement on that place. That's because all the moments, all the BM diagram is going what? Downward. So what it requires is that it's what? It now requires what? Moment. It now requires what? Bars. All right. Reinforcement on the place where the diagram is going, which is what? Downward. So it only requires what? The bottom reinforcement that will be sufficient to what? To withstand the that effect of that moment. Okay, and all that. So it does not require what? The top moment, except there is any what? Hugging moment that's going to go what? Upward and all that. Then that would now require what? A top reinforcement. But just for simplicity and to follow what the code says, when you don't have when your beam does not require a top reinforcement, it is advisable to provide what a minimal reinforcement. Okay, that will give stability to your what, to your beam links. Okay, that's fine. So in that case right now, knowing that this is an end of a beam and this is an end of a beam, what happens is that I'm going to click on this beam right now and right click. So since this is an end and this is an end, here it's meant to be what, pin or hinge, and here also it will be what, hinge. So I will now click on this beam right now, right click now, and then move on to this place that says what, beam end condition. I'll then come here and do what, both end hinge, because this place here is a hinge and here also is a hinge. Okay, so I'll come now and say applied. Okay, selected, and then you will see the 0. This now will not appear. Can you see the 0 here? This thing now means that this place here has a 0 what, moment, because it's an end of a beam, and this other beam also on this beam 8 on this other end is also what, showing as 0. So if I take my hands off now from the beam, you see that that 0 will still be there, showing that this is what, 0 moment. Okay, that's fine. Correct. Now let me now take another example now on this beam, now on this continuous beam, which is beam 1, beam 2, and beam 3. Okay, now on this case right now, knowing that this is a continuous beam, we are going to take it as a full one beam. Okay, but it has different what, span. It has span 1 and span 2, and then the final one, span 3. So basically this is a 3-span beam. Okay, when it comes to continuous beam, right? So in this case right now, the next thing I'll show you again right now is now how to hinge this. So knowing that every end of a beam is to be what, is to do what, is to carry what, 0 moment. So in that case right now, on this beam, on this continuous beam, because this is now a full beam, all right, this is a continuous beam. So on this continuous beam now, all right, on this continuous beam now, this end here, which is this beam here, since there is no continuity after this column, this beam 1 right now at this eye end becomes what, and becomes what, a hinge end or a pin end. Now coming to this other side of the beam, which is the beam 1, on this end after the column there is still a beam continuing, which is what, beam 2. So in that case right now, this we're gonna have what, a fixed end, because there is going to be a hugging moment that's going to exist on this place. Knowing that if I just show you right now how this moment will look like, the diagram look like, you will see something like this. It will come like this. Just see my cursor how it is going to go. It will come from this place right now, being that here is 0 moment. It will come from here and then go all the way down like this, go all the way down. Now on reaching this place, it will just go up somewhere here and then hug like this. All right, now this hugging effect right now have caused what, will do what, require a top reinforcement here. So if this place, if from here to this place where the hugging began is meant to be what, 2y16, this place here, because of this hugging moment here, is going to require more than 2y16. It can require what, 3y16 or 4y16, depending on the size or the value of the what, moment, of the top moment that's going to happen here. Okay, so with this now, since there are going to be a hugging moment here based on geometry, there's going to be a hugging moment here like this. With that, this now becomes what? This now becomes a fixed end. So what does that tell you? In every continuous beam, don't hinge the intermediate what? The intermediate beams. All right? Don't hinge the what? Intermediate support. Only hinge the ends of the support. So in this continuous beam right now, this is an end because there is no continuity after this column what, 1. Okay, so this is an end to this beam 1, and for this mid span for this continuous beam, after this column 2, which is C2, all right, there is still a continuous beam which is going, which is beam 2. So this place right now becomes what, a fixed end. Okay, so I'll skip this place from doing what, hinging, and then if you come here again after the beam 2, after this column 3 here, there is still a continuity on the beam which is now what, beam 3. So in this again, we are still going to have what, a hugging moment here. They're going to come like this, so which will also require what, a top moment, sorry, a top what, a top reinforcement, because it has a top what, moment. And in that case right now, this also becomes what, a fixed end. Okay, and then moving now onto this place right now, because there is a wall here, okay, and the wall and the beam is not the same structural member, so this right now becomes an end to to this beam. Okay, this right now becomes an end to this beam tree here. So in real sense now, for this whole length of continuous beam, it has just two end conditions. It has just two ends, okay, which is one at this column 1, and then skip column 2, 3, and then move to this wall 16 here. Okay, so right now, if we are going to apply a hinge end or a pin end, this place here we are going to apply it as what? Moment at what? 0, and here also moment at what? 0. Okay, that's fine. So in that case right now, I'll then click on this beam right now, right click here, and then come here, and in this case, knowing that this is an I end here, which is your chin here, the left hand side is I end, I'll come here and say what? Update end condition as what? I am at what? At I, which is the left. Okay, you will now see that here will now show as what? 0. Okay, that's fine. Here will now show as what? 0, meaning that meaning what? Meaning that what? The moment here is equal to what? 0. Now in this case right now, you must not hinge a continuous beam at the mid span. So I'm not going to apply anything hinge here. If I come now and apply a hinge here, let me just say come now and apply hinge at what? At I on this. That means that I have done a blunder. Okay, I have gotten it wrong, because this place right now, this place is not meant to do what? Moment cannot be 0 here, because if you draw the diagram here, you will see that the diagram will go like this and then hug like this, which is going to do what? Introduce a top moment. So in that case right now, you have did a blunder by doing what? Applying that this beam is a hinge end. So this place right now is meant to be fixed. Okay, so in that case right now, I'll click back on this beam and right click and then do what? No hinge. Okay, no hinge. So by applying this no hinge right now, it takes here right now to be what? To be a fixed end. Okay, that's fine. I'll then move to the last part here and then come here, right click here and then do what? Here, come here and then come here and then do what? Say hinge at what? J, which is the J end, which is you is now going to see the 0 will now appear here, knowing that moment here becomes what? 0. Okay, now I did this because this was a wall, because this is a wall. Okay, if this was a beam, I'm not going to hinge this end here. I'll continue till where I find the next one. So in this other case right now, this beam 4 right now, this beam 4, looking at this right now, this beam 4 is what? Both ends supported, because after the beam we find what? A wall, and then we'll find what? A column. Knowing that wall, this is a reinforced wall, and this is a what? A beam. They are not the same structural what? System and all that. So because you cannot draw the same diagram together, the BM diagram for this beam 4 is going to start directly from the wall onto this wall here, because wall is also referred as what? As a type of column. All right, it's like it has the same principle when it comes to column members. Okay, I know that. So with this right now, this BM diagram will start from here all the way down to this wall. So in this case right now, this then become what? This then become both end hinge. Okay, now if I don't apply this as both end hinge, what happens is that the moment from the beam will transfer into the column, and you will see that into the wall. And since this is a structural wall, walls are not good in receiving what? Moments. Okay, so in that case right now, the moment already inside the wall and the moment that the beam is transferring is going to induce a very high moment here, and you will see that you're at this part of the beam of this beam now, you will be having something like Y25, a very high diameter of bar. So just to be safe and to not to have that kind of issue, don't allow moment to transfer into the wall. Okay, that's fine. So with this now, and if you also look at this beam right now, this beam right now is already what? Here is what? Discontinuous, and here is also what? Discontinuous. So right now this now becomes what? Both ends what? Hinge. Okay, that's fine. And then if I then continue again, you can see that now it is now showing what? 0 what? 0. Okay, if I then continue again right now on this other side now, here also, knowing that here is a wall, you can see that wall, and here is a beam. This end right now is what? Discontinuous, because there is no beam continuing after this point. Okay, so right now then come here, right click here, and then so what? And then apply what? Left end what? So but okay, that's fine. So with this, you can see how I am applying this, and then knowing that this is a column, and after this column right now there's a beam and there's a beam, so this place cannot be an end of this beam 5, because there is what this now becomes what a continuous what beam. Because if I draw the moment diagram right now, you can see that here will hug like this. Okay, so because of this hugging right now, it has induced what? It has induced a top moment, which require what? A high reinforcement, a top reinforcement on this side. Okay, and all that. That's fine. So with that right now, this place from here to the place where we have the what point of what shear. All right, sorry, point of what where the moment change its direction from bottom moment to from bottom to what top moment. Here right now, this place right now can be what 2y16 and all that, which is the minimal reinforcement. Why here? Knowing that here had the hugging moment here cannot be 2y16, here can be 4y16. So you are going to have additional what reinforcement at the support here at the top. Okay, that's fine. So with this now, I will skip this and leave here as what fixed, because here is going to have what a top what moment, and same thing here also a top moment here, and then this other side here right now, since this beam after this beam 7 there's no continuity here, this now becomes what a hinge end or a pin end at what at the J end of the beam. So I'll come now, right click here, and then come here and do what, and then come here and do what, apply what at J, and then hinge it. Okay, you will see your 0 now will now appear here. Okay, now if I take off my hand right now, you will see that the 0 is now appearing here, which means that the moment here is what 0. That's fine. Okay, so this other one here, just to do what, click on this, because here is an end, and here is also what an end. Right click here and then come now and do what, and then come here and say both ends. Okay, now the number 3 mistake most structural engineers do is to do what, is to apply hinge end and fixed end on their cantilevers. Oh my god, that's the worst thing you can ever do in your life. Okay, because a cantilever beam is meant to have what, a moment that is standard at the support. It's going to have a very high top moment. So cantilever beams actually has what used to have a higher number of top reinforcement than the bottom reinforcement. That's because the moment diagram always goes what, upward. It always goes what, upward, except you are having a very high point load that is coming at the end of the cantilever. Even if you have a very high point load on the cantilever that will make the diagram appears to do what, to go downward, it will still require what, a top reinforcement, because that effect started from what, from the top. It is only because of the point load that the thing is trying to do what, trying to bend the what diagram downward. So it requires a top reinforcement to be able to withstand the point load and all that. So cantilevers always have what, very high top reinforcement. So don't ever you hinge what, apply a pin end on a cantilever. That is the worst thing you can ever do in your life as a structural engineer. Okay, that's fine. So with this now, you cannot go and apply here as what, both ends, or let me say come here, because here is what, discontinuous at J on this cantilever beam. You now come here and apply this as what, as end here. No, you are going to cause issue on this, because if you do this, the software will do what, accept it and go and do what, and go and give you what here as what, 0. But you have just caused an issue on that structure or on that structural member. So I'm going to click it back right now, and then right click now, and then go back to end condition, and then say what, no hinge. Okay, so I'll then come here and do what, and click on what, apply. Okay, that's fine. So never you hinge a cantilever beam. Okay, that will be nice. Okay, so with this right now, with this same procedure, you can see how I have applied hinge beginning from this place here and up to the end here. Have explain to you. So this is how to you are going to apply hinge end on all your beams, okay, on all the beams that have what an end where moment is what 0 and all that. Now most people see this as what stressful, and I've already explained the effect of what will happen when you don't apply what hinge on your what structure. Okay, that's fine. So you can see how this is happening. Now we have a complete course about hinging and what end conditions and all that for on this software. So you can get the complete course on our website. Okay, you can see our website on our bio, right on our bio handle, and you can be able to get that course. And we also have amazing course on flat slab design. We have added a course on flat slab design without column drop. So our advice, if you don't have ideas on how to design flat slab, you can go and get that. Now most people, I have seen people watch, I have seen most videos here on YouTube how people design flat slab. I'll tell you that is wrong. I have watched over 90 videos on flat slab design in Protastructure. That is the wrong way you can ever design what flat slab. They don't even calculate their what column strip width, or calculate what their middle strip width. That is the wrong way to do that. Now we have a comprehensive and well detailed flat slab design course right on our website. And if you cannot get that, you can check on our bio. You will see our website is simply 𝔼𝕚𝕚𝕚.com/Ekidel. So this it is simply spelled www.𝔼𝕚𝕚𝕚𝕚.co, then /Ekidel, and Ekidel design, and you will be able to do what, to get all our courses. And you can also go to our about page. You will be able to see our online store website there. That's fine. Now if you want to enroll for Ekidel mentorship training, I would advise that currently on this month we are on 50% discount on our Ekidel mentorship training. Don't miss this opportunity and all that, because what you learn is in fact it cannot be compared to what you know already. Okay, and also to gain more from Ekidel, I always advise the subscribers and viewers here that you join our membership plan here on Ekidel, which is Ekidel Premium. We have 4 types of membership, which is Ekidel paid courses, Ekidel Premium, hybrid building membership, and then Ekidel mentorship. So you can join any of that and enjoy our exclusive videos. Okay, the videos we like post there are more detailed compared to what we give here on our free YouTube channel. Okay, so thank you so much and God bless. Now if you have watched to this very end, I would advise that if you have not subscribed to Ekidel, please subscribe to Ekidel. And if you're a new subscriber, subscribe to Ekidel. And if you're an old subscriber that have been watching and have gained a lot of knowledge here, to advance more knowledge, I will advise you to do what, to join Ekidel Premium membership here on YouTube. Okay, that's fine. So thank you so much and God bless you. I love you, and see you again tomorrow, which we are going to have our live stream tomorrow. Bye for now, and we love you. Then bye. If you want to learn structural design, then Ekidel is the best for you. By clicking the link, you are already one step ahead. Don't miss this offer.